like zeros and ones, how is 5 represented? I'll look into your chat section. So how is 5 represented in zeros and ones in binary system? Yes, 2 power n is a correct answer. 101. Very good. Very good. Good, guys. Appreciate your n too. Yeah. So let's go to the next part, which is binary to decimal. That is ulta. So we just converted a number to the binary form, zeros and ones form. Now we'll convert zeros and ones to this thing, decimal form. So we have a number that is 10110. We will not worry about the decimal part right now. We will just focus on the whole number part. So we have 10110. So how do you start this conversion? So the number that we have is 10110. Let's convert it into decimal form. Pardon my handwriting. I don't have a stylus right now. I'm using my mouse. So please, apologies for that. So we start first with assigning an index, that is from left to right. So this will be index 0. This will be 1. This will be 2. This will be 3. And this will be 4. Okay. So next, we will first take the index that is 0. So this 0 we are going to consider and multiply this with 2 power the index that is of this number, which is 0. So 2 power 0 plus, I'm going to consider 1 times 2 power. Now this 1 ka index is 1. So 2 power 1 plus, I take 1, multiply this with 2 power the index of this number, which is 2, plus I take 0, 2 power 3, okay, plus 1 into 2 power 4. So what would be the answer? 0 ka to it will get cancelled. I'll have 2 power 1 into 1, 2, plus 4, which is 6. 6 plus 16, that is 22. So this number 10110 represents the number 22 in decimal. Okay. Yeah. So this is how we convert binary to decimal numbers. Now we will come to Boolean algebra. What is Boolean algebra? Boolean algebra is a branch of mathematics that deals with operations on logical values with binary variables. The Boolean variables are represented as binary numbers to represent truths, that is 1 equals true or on, and 0, that is equal to false, which is off, also same as 0 volt, not supplying volt. So this is very similar to the algebra that you might have learned in your school dealing with XYZs, but the only thing here is that whatever variables we use, here also we're going to use variables. These variables are going to can take only two values, that is 0 or 1. That's why the word Boolean. We are considering only two factors here, and that is the zeros and ones. Okay. So as we have learned, I hope you guys are aware of this. There are broadly three types of Boolean algebraic operations, that is and, or, and not. So firstly, to give you a brief, what is and? And is basically you have A and B as the input, and there is some output that is we are getting from these A and B. So A and B, when I multiply them, that is A dot B. Okay, so I get the and I am that means I am doing the and operation. If I add A and B, I am doing or operation. And if I'm what is not, why is this not operation existing? Because again we have two factors in Boolean in binary system, that is 0 and 1. So something which is not 0 will obviously be 1, and something which is not 1 will be 0. So this is the not operations, and these are called as gates. These are represented, like these operations are represented through these diagrams. Okay, now we will play with these operations. Play as it, we're gonna take some variables, add or multiply, or take a prime of them, prime as in take a not version of them, and we will see what we can learn from that. But before doing that, we will go through some operations which you should know. Okay, but before that, I request you to go through this De Morgan's theorem, where if I have OR of input of two inputs A and B, and if I take prime, or in this case it is represented as a bar. So bar means that there is I'm taking the not version of it. I'm sorry, I have actually repeated this. I didn't notice the mistake here, but this is the theorem, that is prime of OR will give me and of two primes, right? So similarly, this one you can see this is the second De Morgan theorem, which should have been here, but I did some mistake here. So AB prime will give me A prime plus B prime. Okay, and A plus B whole prime will give me A prime dot B prime. Okay, this is the basic of this is De Morgan's theorem, and this is useful. We will be using it in the upcoming slides. So again, recap of logic gates. This not or and we just went through it. The table here, that is the input output table, is called as the truth table. Since again, as I said, A and B can take only either 0 or 1 as a value, we can make this truth table, right? We can take combinations and we can say what might be the output. So these are the other types of gates. What is NAND gate? NAND gate is basically A dot B prime. So what is not A dot B is NAND gate. What is not AND is NAND. And NOR is what is not OR. And XOR is A plus B dotted with A plus B prime. Now, how do we get this? When we try to simplify this, we're going to get a very simplified version of this. I would like you to take a few minutes and try telling me what might be the simplified version. That is, I urge you to solve this, and I want you to use De Morgan's theorem that we just studied. I'll be looking into the Q&A section for the simplified form. Yeah, 22 was the right answer. What is prime? Prime is basically not something. A prime B plus AB prime. Very good. Very good, Pratnyan. Good answer. Anybody else? I think this might be easier for people who have studied all these prior, but I would love it if you guys can attempt, to simplify this. Yeah, I will explain how we are getting A prime B plus AB prime. So we have A plus B dotted with A plus B prime. Let's simplify this. Okay. So using De Morgan's theorem, I'll get A plus B dotted with A prime dot B prime. Okay. And I apologize for the handwriting here. Okay. So when I multiply this individually, I'll get A maybe I might have made a mistake here. Just a second. There is some error that I can think there is some problem, but just know that this basically simplifies to A B prime plus A prime B. And what does XNOR simplify to? XNOR is basically uh, this, that is AB prime plus A prime B ka whole prime. So can somebody tell me what does this simplify to? AB plus A prime B, B prime. Very good, very good. So let me tell you how does this happen. So we have the expression A prime B plus AB prime, and we are taking prime of this. So this will give me, using De Morgan's theorem, this will give me A prime B whole prime plus dotted with AB prime whole prime. This will eventually give me A prime of whole prime plus B prime and this I'm gonna dot with A prime plus B, and this will give me A plus B prime, because A prime of prime of A prime will be A, and this dotted with A prime plus B, and this will give me AB plus BA prime, and B prime A prime. So why is this? Because A prime is going to be 0. Remember that A prime is always 0. Why? Because again, if A takes 1, A prime will be 0. If A takes 0, then A prime will be 1. So anyhow, when I multiply them, I'll get 0. Okay. So this is for X and R. This is for X and R. And XOR will be AB prime plus A prime B. Okay. And I'll send you the algebraic proof of that. Okay. Now we will, again, as I said earlier, we will be using these operations and we'll be constructing our own equations. So let's choose some variables, say X, Y, and Z. Now, can you guys make some combinations using these variables and their primes? That is, I will give you 6 variables, not 6 variables, but 3 variables, but I'll give you 6 options. I'll give you X, Y, Z, X prime, Y prime, Z prime. So can you like multiply, add, do whatever you want. Pick two, other two, add them to that, do something, and can you send me the equations in the Q&A section? Can you make those equations and share in the either Q&A section or chat section?
Hello everyone, I am Anish.
Guys, did you get my question, right? Yes, very good. Rajshekhar has sent me XYZ plus X prime, YZ prime, X prime, Y prime, Z. That's a good answer. Any other? You can take any combinations. Need not be that each term should have all the XYZ. Okay. XY plus Y prime Z. Very good, Sriram. So, uh, so there are like combinations that I'm getting here, right? And I can make so many combinations because I have 6 options, right? X plus Y C prime plus Y. Very good, Arjun. Yeah. So I'll show you. Yeah. So let me take a very simple combination and let that be. Let's say it is something like X prime Z plus Y Z prime. And again, there are many more as you guys sent me. Now these combinations are called as Boolean functions. So whatever you see in the Q&A section, they are all called as Boolean functions. Why a function? Because it has an input and it has an output. And that output is determined by the operation that we do on the input, which is exactly what happens in the mathematical functions that we have studied, right, in schools and all. So we have an input, output, and we have an operation that's determining how the output is going to be, right? So that's why this is a Boolean function. Now, logic diagrams and expressions are defined by 3 components. The 3 components constitute these. One is the truth table, which takes the values that x, y, z can take, and the output that it gives. There is the logic equation which tells me how the operation is done, what is the operation that's being performed on the input. And then we have the logical circuit that we can build using logic gates. Okay. So Boolean equations, truth tables, and logic diagrams describe the same function. So all these three are conveying me the same function, right? Truth tables are unique, but expressions and logic diagrams are not. This gives flexibility in implementing functions. So as we will see further, we will also learn that the same output can be the expression for some output. We can write multiple expressions and those expressions need not be same always. Okay. This question, I will come back to it if I have time. Okay, if I don't, then we will proceed further. Okay. So postulates and theorems in Boolean algebra. These are the basic postulates. In this, you can see the De Morgan's postulate is also properly mentioned. And I'm sorry for the confusion in the slides. I'll change that part. But what is most interesting of this is the postulate 5 distributive property B part. That is the one in blue color. X plus YZ equals x plus y into x plus z. So let's try simulating it in logism. So what is logism? I'll stop sharing my screen. Yes, I'm getting a lot of answers for these Boolean functions. Very good, guys. Very appreciated. Yeah. So is my screen visible? This is a logism screen. Okay. So what is logism? It's a simulation, this where we can build our own logic gates and we can test, right? So let me try building the one that we just looked into, which was x plus yz equals x plus y into x plus z. So first let me build x plus yz. So for which first I'm going to take an AND gate. And this will have two inputs, and I'm going to take an OR gate. Okay, and this will also have two inputs. Hope the screen is visible, and I will connect. Yeah. So in this, the square icon is used to provide an input, and this circular icon is for the output. So this will come here. Okay, I'm gonna name this as X. This will be Y. And this will be Z. And this will be X plus YZ. Okay, So now this represents the LHS of what we saw in the Canva screen, Canva slides. Now the RHS was x plus y into x plus z. So I'll first take two OR gates. This will have again two nodes. And then an AND gate. So one terminal, I'm going to connect these two. Let this be X. So this represents X. This represents Y. And this will be Z. And this is the output. So this is used to assign input. Okay. This I'm going to name as X. This will be Y. And this will be Z. And this will be X plus Y into X plus Z. Okay. Now let's try. Okay, so the X, Y, Z, all the values are at 0. Let me make X 1 and keep Y and Z as 1. What will be the output? I'm getting it as 1 in both the cases. If I make Y as well as 1, I'll get 1 only. But let me switch off X to 0. It's going to 0. What if only Z is 0? In this case, I am getting the output as 0 in both the cases. Now let me make X and Y both as 1. What will I get? X and Y both are 1. That will give me again 1. What happens if both Y and Z are 0? Y and Z both are 1. So with each click, I'm able to change the input values. So again, the output will be 1. What if Z and X are 1? In that case also, the output is 1. What if, let me say, all the X, Y, Z are 1? In that case, the output will be 1. So you can see that uh, I took different cases and I tested and I'm getting same outputs for both these logical gates, which proves this postulate, that is X plus YZ equals X plus Y into X plus Z. So I have proved this part, that is postulate 5B part, because this is a little tricky. Now I will encourage you to find the proof in algebraic way. Prove it in the algebraic manner, okay? Without using logism, can you try proving it, okay? So let's go to the next part. Yeah, that is exploring different types of Boolean functions. So Boolean functions are broadly divided into two types, that is canonical and standard. So what is canonical form? Each term of Boolean expressions contain all input variables either in true form or in complement form. So in your Q&A section, somebody sent me an equation of two terms, each term having x, y, z, right? So that was the canonical form. So here, before we look into further, I want to define certain things. First thing is that this is f represents a function here in the first example. And the function is made up of three variables, that is a, b, and c. So here a, b, c are the variables, while I have the function contains two terms, that is the sum. So this represents a term. And what is a literal? The each part of the term is called as a literal. And this example, the first example, is in the form of sum of products. That is, I have products and I have added them. Okay. So the above expression contains six literals, that is three in each term. So total of six literals. It is three variables because the function is constituted by three variables, that is a, b, and c, and it has two terms. Now I have another example here, that is f of a, b, c, d, and this is the expression. So this is also said to be in canonical form, right? So how many literals, how many variables, and how many terms are there in this function? Can you text me in the Q&A section? Yeah, how many variables, how many literals? Four variables, 12 literals, and three terms. Very good. Very good. Yeah. So, yes, so this equation has it's constituted of four variables and it has three terms, and each term has four literals, so a total of 12 literals. And this is also in the form of sum of products. So what now, this was canonical. Can you guess what might be standard form? It's very easy to guess. So can you guys guess what might be standard form? Yes, we will be sharing link to download Logism. We will also we'll give you instructions on how to do that. Next session, you guys will be doing a lot of stuff in Logism. So yeah, what might be canonical form of Boolean function? Okay, so canonical is something which is, standard. Standard Boolean function is something which is not canonical. Something which, so canonical is what? You have a term and that term has all the variables. They might be in their not form. That is like, they might be in their, prime or, not kind of form, but they still are there. So in each term, you have A, B, C. What if it's just AB without C? Then it becomes a standard form. So this is the yeah. What is standard form? Something that's not canonical. An example is, as I said, A prime plus ABC. So while the second term has all the three variables, the first term doesn't have B and C, and it has only A. Okay, so with this, I complete the basic introduction to Boolean algebra. I hope you guys are clear with it. If you have any doubts, feel free to text in the Q&A section, as well as ask in the you can DM in the DM me, or message in the WhatsApp group. I hope you enjoyed this part of the session. From after this, I'll hand over the session to Akshya, who will teach you much more interesting stuff with whatever tools that we have learned so far. Thank you, guys. Akshya, you can take over.
Hello guys, hope I'm audible and I'll start in a minute. So all the basic stuff is pretty much clear with all of you guys. So with those tools, as DPS said, we are going to be building on some more stuff before we finish today's session. So I'm going to be starting with some basic introduction of some terms called min terms and max terms. First of all, you guys don't even have to worry about this example itself. It will be clear what I'm wanting to tell you guys. So suppose I'm having two variables and let's call them x and y. And I have to, find the terms which are in the and form or, dotted form. For example, xy or something like that. Now I'm going to ask you guys, like how many terms are possible of the form AB such that A can be x or x dash or x prime and B can be y or y prime. So I'm just asking you the number of combinations. I know typing all of those is going to be taking some time. So I'm just asking you the number of combinations which are, kind of possible here. The number, that's it. So you guys can put that in the Q&A section and I'll check that out. 4, yeah, perfect. It's actually 4 combinations are possible. Anybody else with any other answer? Okay, so I take it that you guys all agree with 4, which is absolutely right. So how are 4 terms possible? So I've told that A can take either x or x star, x prime, and B can take y or y prime. So there are basically 4 combinations which are going to be possible: xy, xy prime, x prime y, and x prime y prime. So that's basically what I have put here. So these terms are actually called as min terms. That is, if you're writing it as some dot or some, and kind of terms, these are called as min terms. So a bit more detail on min terms. So what are min terms? It is simply the product of n literals, each occurring exactly once. That is, you cannot write x prime together and call that as a min term. That is not allowed. It can be xy prime, x prime y, something like that. That's all acceptable. Okay. And this is called as sum of product terms, which some of you had mentioned for the standard form. This is actually SOP, sum of product, or this is also called as sum of min terms. So what do I mean by sum of min terms? Is some function like this. Say AB plus A prime B prime. So you might be wondering, right, why is it of this form only? The thing is, the output of some min term function always has to be 1. And that is, it works on active high. So if you take this, how am I telling this is some, SOP form, or, how is this min term function valid? Let's assume A and B is both of them are 0. The output for this is if A and B both are 0, this is going to be 0. I'm performing an OR operation, and again, A prime, B prime, both of them are high. AND operation on both ones are going to be 1. So whatever combination you're going to be taking for A and B, this, function will always output 1 as the result. That's why this is a min term function. Okay, so that's all about min terms. So we are moving next on to max term. So what do you think max terms are? Before we even go to that, again, I'll give you an analogy which will make it really easy for you guys to understand. Let's say I'm again considering two variables, x and y. And instead of the AND operation which we performed lastly, we'll perform an OR operation now. Like, A can take x or x prime and B can take y or y prime. Now, again, what are the different combinations of AB which are possible? Again, like A plus B actually, not AB, A plus B which are possible. Again, there are y plus prime, x prime plus y prime, and x prime plus y. So these are basically called as max terms. That is some kind of, OR operation on variables. Okay, so a bit more on max terms. So max terms is simply the sum of n literals, each occurring exactly once. So exactly once in the sense you cannot write x plus x prime as a max term. That is not allowed. This is some kind of logical OR operation on distinct literals, right? And this is called as product of sum type. And this example will make it clear what I mean by product of sum. So these are sums which are kind of, dotted or producted, multiplied with each other. And this is a max term function. And as you can notice, the output of a max term function is always 0, or this works on active low. This is exactly the opposite min term. That's it. Like where, in min terms, you are, dotting you are performing an AND operation on each term and adding all the terms together, right? Here you are adding, the term consists of addition of variables, and you are, performing some multiplication or AND operation on them. So this is basically it. And as you can notice, the output is always going to be low. Let's say, I'm having A is 0 and B is 1. So A plus B will obviously be 1, and A prime plus B prime, however, will be 0. So the dot will always be 0. That's all. That's what I mean. So that's min terms and max terms. So is this part clear with you guys, or is there any doubts? You can put it in the Q&A section. There is any doubts? Wait, isn't the slide still on min terms? Wait, you guys are not able to see the current slide, is it? Can you guys respond if what is the last slide you guys are seeing? Is it the one on max terms or is it something else? Can you guys confirm? Hello? Deepti, what is the last slide you can see?
Max terms. I think it's correct.
Max terms. Okay.
Yeah.
Okay. What is active low? Oh, active low is basically that whatever you, it's always going to be low. Whatever combinations of A and B you're taking, right? Either either of them being 0 or 1 or whatever combinations, the output is always going to be low. That's what it's meant by active low. Okay, so this part is clear. So I'll be going on to the next topic, which is going to use this concepts which you have learned, and that's called as K-maps or Karnaugh maps. So this is exactly how a K-maps looks. I'm not scaring you guys. It's actually not complex. The thing is, if you're actually trying to algebraically, simplify functions, I'll show you examples of that. Those are going to be, more and more difficult with increase in the number of variables. That is, if you have just 2 variables, it's very easy to find the functions. But if you have, say, 4 variables, it's going to be really hard. Like you'll have to, think of what formula, like as Deepti has showed you, there are a lot of postulates and theorems which are present in Boolean algebra, right? So you'll have to think at each step, is there any simplification possible? All of that. So it's kind of very hard to proceed algebraically. And that's where K-maps are kind of used. So there's simply a pictorial representation of Boolean functions. Okay, and map, the most common map we know is this map. But now from now on, if anybody says map, Karnaugh maps are the only things you guys are going to be remembering. And these are pretty interesting also. And there are different types of K-maps. Actually, 2D K-maps, 3D K-maps, 4D K-maps, 5D K-maps, and 6D K-maps. But we are going to be discussing only the first 3 types. And the last 2 are actually not efficient. Now, I've told you that. You might be wondering, what is the basis of classifying into all these types, right? So the basic classification type is based on the number of variables which are present. Yes. Excuse me. Let's suppose there are 2 variables, X and Y. So you're going to be preferring 2D K-maps. If there are 3 variables, you're going to be going for 3D, and the same applies for the next. So 2D K-maps. So as I said, you're going to be having 2 variables here. So 2 variables, and each of these 2 variables can accept 2 values, right? Zeros and ones. So totally, how many terms are we going to be dealing with? 4 terms. So this is a 2D or a 2D K-map looks. So this is like you are going to be having 4 terms. So, this might look complex, but it's pretty simple. So let's do this step by step. So let's say this is the basic structure of a 2D K-map. And there are 2 variables, X and Y. X can accept 2 values at most, 0 and 1. Y can accept 2 values, which is 0 and 1. So let's assume I'm always taking my most significant bit, or the first bit. Let's assume the first bit, we are always taking it to be X. And the second bit is always going to be Y. You can, keep it other way also. It's just for consistency. That's it. You can keep it XY or YX. It's up to you guys. So let's say, when you're combining, what are the terms which are possible? 0, 0, 0, 1, 1, 0, and 1, 1. 4 basic terms which are possible. And while we are writing the notations for these terms in K-maps, and let's assume you're going to be finding some, sum of product terms. That's the most commonly used thing. So we are going to be only sticking to min term usage. We're not going to max terms, but it's exactly the same. I'll be telling you how it's similar in the coming slides. So basically, that's why I'm using x prime y prime. That is, what did we tell when we are discussing min terms? The output is always active high, or the output is always 1. So to ensure that each of the individual terms also, we are always keeping it to 1. That's why 0 0. If xy is written then and both of them are 0, then it's gonna be low. So to keep it as active high, we are gonna be using x prime y prime. The same thing, both of them are 1. So basically, that's it. So if you look at the arrangement of K-maps, right? So how is this basically done? It actually is done on the basis of similar, the terms which differ only by 1 unit are kept close together. So what do I mean? Let's assume the 0, 0 and 0, 1. They differ only in one place, but it's only different by 1 unit. Let's take these two boxes, 0, 1, and again these two boxes, 1, 0 and 1, 1. They differ by 1 unit. 0, 0 and 1, 0. Again, they differ by 1 unit. So this is basically all that you need to know about 2D K-maps. Okay, and let's talk about a function. Let's talk about an example so that it becomes very easy to talk about this K-maps. So, you can actually look at this and, find out what the function is. Right, can you guys guess what this function is? I'll give you a hint. It's based on the function value 1 and min terms. We're talking about min terms only, and I told you how to represent min terms already. So can you guess how this function is going to come out? Put it in the chat box and I'll look at it, or the Q&A section, anything. Oh, I'm sorry, my voice is breaking, is it? Okay, how is it now? Is it still the same or is it better?
It's fine now.
It's fine now, okay.
Yeah.
So can you guys find out what the function is and put it in the chat box? It's fine if it's wrong, guys. I just need, I just want you guys to understand what's going. X plus 5. Okay, that's the final function. That's wonderful. Okay. You guys can write a simplified version also, like, summation of 3 terms. You can write it like that also. X plus 5. Okay. OR gate. Nice. Pretty nice, guys. This is actually very good. So many of you have replied perfectly correct. That is the final answer which we actually aim to get. The OR gate. Exactly. That's the OR gate. True. Good. There's actually another way of looking at this. I'll go and tell you that method also. So since this was an OR gate, it was pretty easy for you guys to, figure out what it is, right? But let's suppose this is some unknown function. Then there is certain, problems which you might face. So we'll break this function. So this function is high when x is 0 and y is 1. So if we write it as sum of products term, then this becomes x prime y plus xy plus xy prime. So how am I getting this? I'll go back again. So this function is 1, right? Wherever the function is 1, you will just write those terms. That's it. And you will write that as sum of products terms. As I told, it's really most commonly used. You can write it as product of sum method also. It's up to you guys. But we're dealing with the SOP form here. So here x prime y plus xy plus xy prime. That's basically how this function is written. That is, wherever the function is high, you will write each min term. That's it. So that's basically what I have written over here. Now I'll go to the K-maps for simplification. You guys might be thinking this is completely unnecessary, right? Because it was very simple to find. It was an OR gate. But I'll show you complex functions, or when there are more than two variables, then it's going to be kind of hard to figure out what it is representing. So if I'm trying to solve this function algebraically, then I can obtain, two. If I can use two methods. I can use multiple methods. One, I can directly simplify terms. Like, I can take this xy and x prime y, and I can take y common and write x prime plus xy. And x prime plus x is always 1 because that is an OR operation. So this is going to simplify to this. Or I can use x plus x equals x. That's another postulate which is available in Boolean algebra. And I can simplify to y plus x, the OR gate which you guys were talking. So, this is kind of confusing, right? I mean, mostly we would have been, prone to use the first method. So what can we do is we can go to K-maps and simply write this term. So wherever we have these terms, I will go and put a 1. So x prime y, which is this block, I'll write a 1 there. And x y, which is 1 there. And xy prime is this block, I'll go and write a 1 there. You might be wondering, right, what m0, m1, m2 and m3 is. It is just another way of, calling terms. Instead of calling it x prime, y prime, I can call it m0. That's it. And instead of calling it xy, y x prime or something like that, I can always call it as m1, m2, m3. That is another simplified way of writing it. And now I will try grouping stuff. Like, how is grouping done? It is done in powers of 2. I'll explain the rule so that it becomes clearer. I'm just showing this example to you guys. So I will try grouping terms together. And how are terms grouped in Boolean algebra? It's in powers of 2. So it can be 2 power 0, which is one term can be grouped together, 2 terms can be grouped together, 4 terms can be grouped together, 8 terms can be grouped together, and so on. So, and the best thing is you will always have to try to group more number of terms. That is one of the requirements. For example, if there was a 1 here, then I could group all these together and say, and put all of them together in one box or, one grouping. But that's not there. So I cannot group 3 terms together. That's not allowed. So I'll have to group two terms together. So I'll go and group it like this. This term is one grouping and this term is another grouping. Okay, and how do I, express these terms? Let's go with this red grouping. So these terms, they actually only differ in the y position here. And so what is the x position? X is 1, so I'll write it as x. And here, if you see, it is only the x term which is varying and the y term is already high, so it is 1. I know this might sound a bit complex right now, tools, and I'll again repeat this example. And even if there is any doubt after that, I'll come and read it. So what are the generalized rules which are available? So you will draw the number of squares as the requirements which are given in the question. So what do I mean? The requirements given in the question is, from the question itself, you will see, right, the number of variables which are present. If there are 2 variables, you will draw a 2D K-map. If there are 3 variables, you will go for a 3D K-map and so on. Right, that's what. And with that, you will generate the required number of variables and you will plot the squares in the required forms. So I told you we're going to be dealing only with SOP form, a sum of product form, or minterm function. So if whatever term is there, right, in the function, I'm going to be representing that term with 1 in an SOP form. If there is a POS form, I'll go and fill in 0 in that place. That's the only difference. And as I said, you're going to be grouping in terms together in the powers of 2. That is 2 power x. And you'll always have to keep in mind that maximum number of terms have to be grouped together. It's like, instead of grouping 4 terms together, I can group two terms together. I can group each term separately. That is also there. But you always have to keep in mind maximum number of terms have to be grouped together. And then you'll have to identify the variable which is not varying in each group, and you'll have to combine accordingly. So what I mean by that is, see, if I'm talking about this red section, you can see that only only one term is varying, and that is the y term. The x term is remaining constant. It is 1 only, right? So that is the term which you're going to be enclosing. So I'll call that x. And you can ask, no, why x, why not x prime? As I said, you're talking about min terms. Min terms always have to be high. So each individual term is also, made to be high. So x is written. And from this thing, again, the x term is varying, the y term is constant, and it is already high. That's why it is becoming x plus y. Okay. And that's exactly how this mapping is done. So before I move to 3D K-maps, you guys can, if there are any doubts, you can put it in the Q&A section and I'll clear that. Is there any doubts, guys? Or do you want me to give you another example with this 2D K-maps itself? Or do you want me to proceed with 3D K-maps? Do you want me to reduce the pace? Anything, just put it in the Q&A section. I'll wait for 2 minutes. If there are no messages, I will assume that you guys are pretty much clear with it and I will move to 3D maps. Any doubts? Anything you guys are not understanding, not able to follow? No, okay, you can proceed. Okay, I've got one answer. The person is clear. Rajshekar is clear. Anyone else? Anyone else wants me to repeat? Or is it fine? Can I proceed? And remember, guys, K-maps is going to be the basis of everything else you're going to be doing in the next session. So make sure this is very clear. I know 2D K-maps are not really hard, but 3D K-maps are, somewhat most important thing. Okay, any complex example? Can you give one more example? Okay. Actually, two complex examples which are possible, but I'll go and give you guys another example for this map itself. Okay, I'll go and change this function. So let's say, whenever this is 0, it is becoming 1. And I'm just changing the function, that's it. So, what do you think the function is now going to be? It's going to be x prime y prime plus xy plus xy prime. That is how the function is. So I'll go and change the function. So it's going to be plus xy plus xy plus xy prime. Yeah, so that is the function which we are going to be having right now. So I'll change it in all these slides. I'll leave it in this slide. And so that is the change which I'm going to be using. So there is x prime y prime and the next term is going to be, and next is I'll just one. So this is xy prime. So that's also going to be included. So I'll leave that one there. And I don't have right? Actually different from the previous thing because we're talking about 2D maps, right? And they are actually not really difficult. So when we go to 3D maps, I'll give you more examples and it'll be even clearer there. So this, again, I'll have to change the grouping here. So this term is there and this term is not there. So again, I will group these two together because I can't group 4 things together and I can group two terms together. That is possible here, right? So I will group these two together and these two ones together. So now what the function is, what do you think it will be? So if I'm talking about this purple thing, right, the first term alone is not changing. Like the first term is changing and the second term is remaining constant. And the second term here is actually, here I've used, y as the second thing. I just changed, or let it be, it's fine. So here the y term is not changing. I mean, y term is not changing and it is 0. So I'll represent that as y prime. And the first term is again, here in this thing, the first term is not changing and the second term is changing. So the x term is remaining the same. So what do you think this function is? I'll just, go back to this slide and make the change. So this is actually x plus y prime. Okay, hope this is clear, right? Or I'll put this solution in the next thing. I don't want it here. I'll put it in this grouping part. And this is exactly how it is done. Am I clear? Like with this example? Or is there any doubt? Oh, voice is cracking, is it? Is it fine now? Is it fine now? I'm so sorry. I don't know why my voice is cracking.
No, it's fine now.
It's fine, okay. I'm so sorry, guys. Is this example clear with everybody? We'll deal with more complex examples so it becomes clearer there. And if you've understood this right, whatever we're going to do next is going to be, easy. Oh, you want Ishwara? Ishwara will take some other session, not today. I'm sorry. So we'll move on to 3D K-maps now. So with all of this clear, we'll go to 3D K-maps. So 3D K-maps is what you're going to be having 3 variables. So I'm going to be calling those 3 variables X, Y, and Z. So how many, how many unique terms can we generate here? We can generate 8 terms. So this is how the 3D K-map is going to look. So you might still think, why are we represented M0, M1, M2? That's because it's kind of easier, instead of having to write X prime, Y prime, and all of that repeatedly, this is the notation which is used for min terms. So I already told you that terms which differ only by 1 unit have to be written close together, right? And for y that, as I already told, you can generate, 0, 0, 0, 1, 1, 0, 1, 1. And for x, 0 and 1 are the only possibilities. But if you look at these two terms, right, 0, 1 and 1, 0, what do you notice? They differ in 2 places, right? Here the 1, here 0, here 1, here 0. So I'm going to actually slightly reverse these last 2 columns and we are going to arrive at this structure. So this is how the min terms are actually placed. M0, M1, M2, M3, M4, M5, M6 and M7. And why have I put this arrow? This arrow is just to tell you guys that a different type of grouping is possible as opposed to the other one. Like, 1, 0 and 0, 0 also differ by 1 unit. So I can group terms like this also. That's something you guys will have to be careful when it comes to, higher degrees of K-maps. That's the thing. So we'll go to an example and it will become much clearer there. So let's assume I have such a function. Okay, you guys want to go a bit slow. Fine. From here I'll go slowly. So I have 3 variables again, and the function has 1 in all these 4 places. So can you guys think of, just in terms of min terms, just as an SOP form, can you tell me what the function is going to look like? I'll give you guys some time. Sorry about that. So I'll give you guys some time. And what do you think this function is going to be? Like this function, you can see it. I always want it in min terms form. So this is the first term I'll tell you guys. It's going to be x, y, z prime. So think about what the next is going to be. Any guesses, guys, what the function is going to be? Even if it's wrong, it's fine, guys. You can always put it in the answer. I just want to know if you guys are, following, or if there is anything I'll have to repeat, I'll stop and I'll repeat that. That's fair. So what do you think the second term is going to be? You need not put the whole function also, just put the second term. What is the term corresponding to this line? That's it. X, Y, Z. X, Y, Z is also there, but okay, that's also there. That's correct. But I'm talking about this function, like, this column. The one which I've highlighted, right? The one here. What is the term corresponding to that column? X, Y prime, Z prime. That's wonderful. Oh, you've given me the whole function X, Y, Z prime plus X, Y prime, Z prime plus X prime, Y, Z plus X, Y, Z. That's wonderful. Thank you for the answer. So are you guys following, or do you want some more time to figure out the function, or can I proceed? I'll wait for 1 more minute. If there are no doubts, I'll proceed. Yeah, X, Y prime, Z prime is the function which is. Okay, you've given me the final answer, is it? X, Z prime plus Y, Z. I'll verify and I'll let you know. Jawahar. Okay, so you guys are understanding this pretty good. So we'll go and figure out what this function is in the SOP form, the basic SOP form. So here is a 1. So what is this? X, Y, Z prime. Plus, there is a 1 here again. So it's going to be X, Y prime, Z prime. And there's another 1 here. So that's going to be X prime, Y, Z. And there's another 1 here. So X, Y, Z. So that's basically what this function is going to look like, right? So this is the function here. So we'll go and drop the K-map. Since there are 3 variables, you're going to go and use 3D K-maps, right? So like item will be some X or X prime or something like that. Next Y or Y prime, next Z or Z prime. That is the structure which we are going to be following. So this is X prime, Y prime, Z prime, and this is X. Uh, this is going to be X prime, Y prime, Z. This is going to be X prime, Z. This is going to be Y and mark these down in the respective place. And whatever terms are here, I've gone and put a 1 there. So as I told you, again, group, if there was another 1 here, no, our function would have really been simplified a lot. We'll just have put, one box, got done with it. But sadly, that's not possible here. And I cannot mark 3 terms together. So I'll have to go in PowerShift 2. So 2 I can mark together, right? And this column, as I said before, this column and this column can also be grouped together. So I'll group these 2 together and these 2 together. So this is exactly how the grouping is going to look like. And if I'm talking about this red grouping, right? So what is the thing which is changing? X is changing, Y and Z is not changing, right? That's why I've put this 1 on top. It's kind of easier to figure out from this itself, or you can go and read these individual terms, right? You can see that only the YZ part is remaining the same and it's already high. So we are going to be writing YZ there. And the next term is going to be coming from this orange box over here. So what is this? Or in this orange box, what is not varying? X is remaining at 1. You can see that. And Z is also remaining at 0. So we are going to be writing that as XZ prime. So overall, the end result becomes YZ plus XZ prime. Is this clear or you want me to explain once more? You can put it in the chat.
Akshay, your voice was actually breaking while you were teaching that part. Can you try rejoining?
Fine, I'll try. I'll try rejoining. 1 minute, please.
Mm-hmm.
Hello, am I audible now? Is it any better?
Yeah, you're audible now.
Okay. Fine, I'll go and re-explain this part since my voice is breaking during that part. I'm sorry for the network issue, guys. So we'll again go back. I hope till the function, representation, everyone is clear with it, right? So I'll go and start presenting from here. So this is the function which you have. And as you guys can see, there are 3 variables, X, Y, and Z. So I'm going to be going and proceeding with a 3D K-map. And these functions I have, wherever this term is there, I've gone and put a 1 there. So this is X, Y, Z prime. So this is going to be this part. This is X, Y, Z prime. You can actually figure out from this 1, 1, 0 configuration, right? As I've told you, the first term is something related to X. Second term is something related to Y. Third term is something related to Z. So this is X, Y, Z prime. And I have the next term is X, Y prime, Z prime. So this is going to be 1, 0, 0. X is already high and Y and Z are 0. When representing men terms, I'll have to make them high. So this is the term there. Then I have X prime Y Z, which is going to be this term 0, 1, 1. And then I have X, Y, Z. All of them are high, so this is going to be 1 there. And then I'll have to group them together. That is the next step, right? So how is this grouping done? Grouping is done in PowerShift 2. And I'll always have to ensure that maximum number of terms are grouped together. If there was one more one here, right, I could always have gone forward and grouped all 4 together and be done with it. But there are only 3 terms in close vicinity as far as I can see. And there is one term like this and this. So I will go and group it in PowerShift 2. I'll group these 2 together and I'll group these 2 together. Right, and that's how the grouping is done. So you can see this grouping. One is in red and one is in orange. So how, in this red group, what can you figure out? The X term is changing. It goes from 0 to 1, but the Y and Z term is remaining constant, and already Y and Z are high. So this thing constitutes the term YZ. And if I'm talking about this orange group, the X part is remaining same. Y goes from 1 to 0 and Z part is already, it's 0 and it's remaining same. So what is the term which I'm going to be getting? It's going to be XZ prime. So this is the final simplified version of this function and it is YZ plus XZ prime. Is this clear right now? Is this clear or do you have any doubts? You guys can put it in the Q&A. Do you guys want me to put one more example, like once more one person has asked? Yeah, XZ prime plus YZ, that's right, Arun. Do you guys want me to repeat? Do you want me to give one other example? Or is this fine? I'll wait for a second for you guys to type it out and then I'll proceed. Do you think you guys need one more example to make this really clear? If you want, put a yes in the Q&A section. Yes, with simpler example. Okay, you want one more time, okay. Okay, so I'll give you another example, maybe a bit simpler as someone has asked. Okay, I'll go and change the question here. Let's say this becomes 1 here. And this term is becoming 0. So I'm working on this example from the beginning. And okay, let's say I'm only having 3 terms where it is becoming high. Okay, so this is the new function which I'm having. So what is this function going to be? It's going to be x prime, y prime, z prime plus x, y, z prime plus x, y, z. So I'll go and change it here. So what's the new function which we have? It's going to be x prime, y prime, z prime plus x, y, z plus what was the third thing which we had? We had x, y, z prime. X, Y, Z prime. So this is the new function which we are having. I'll go and I'll change this part. Okay, so we'll have to change wherever the ones are there. So X prime, Y prime, Z prime is this column. So I'll go and put a 1 there. X, Y, Z is already filled and you no longer have this function. So I'll go and remove it. And this is already there. X, Y prime, Z prime is no longer there. So I'll go and remove this. So this is the new function which we are having. Right, so we'll go to this. So if you see, I'll again have to group in PowerShift 2. So you see that, this column and this column absolutely has no connection. So I'll have to group these 2 together and this together, right? So I'll go and I'll add. So first things, wait, I'll just copy this rectangle from here. I don't want color. So I'll go no color. I need a border so that you guys will be able to see. And we'll put that border in say purple. Oh my god. Purple border and no color. So this is going to be grouping number 1. And there is another grouping which has to be done, which is going to be this one over here. So I'll just Now make this kind of smaller. Change the color so that you guys will be able to differentiate. I'll make that say yellow and I will put it over here. So these are the two things which are possible over here. Right, so what do you think the function is going to be over here? You can see that the z part is changing, but the x and y remain the same. So the new function which we are going to be having is going to be xy plus x prime, y prime, z prime. Because there is no other grouping, I'll absolutely have to write what this term is and it becomes xy plus x prime, y prime, z prime. Is this clear with you guys? Is this example clear? This was relatively simple and you guys got to see, right, where you have to convert, where you have to use only one term in the group and something. Yes, it's clear. Okay. How do you convert to POS form? So POS form, what you do is instead of, you will write this function in, instead of writing as X, Y, Z as, some AND function, you will go and write it in the plus form, like some X plus Y plus Z type, and you'll have to ensure that each term is already 0 because it will be a max term type, right? So it is active low. So each term has to be 0 and finally you will dot everything together. Is this clear? Yes, understood. Done. So this was actually most important, 3D K-maps with minterms SOP form is the most important thing and most commonly used. That's why we have talked about this, but I'll go and explain 4D K-maps also. So you guys will begin appreciating, how complexity builds with the increase in the number of variables. So we'll start with 4D maps. So 4D maps, again, how are 4D maps made? They are based on 4 variables, right? Let's call this 4 variables, W, X, Y, and Z. So this is how we are going to be using the 4 variables, and each variable can take 2 values, zeros and ones. So you'll have 2 power 4, that is 16 possible terms which are there. So this is how we're going to go and represent those minterms. So as I told, M0, M1 is another standard way of representing the terms. If you're not comfortable, you guys can go and always write, X prime, Y prime, Z prime, W prime, something like that. And I told you that when you're grouping stuff, you need terms which differ only by one unit placed close together. Right? Again, this issue we resolved in the 3D maps, right? Same thing happens here, but twice. Like you see, there is a 0 and 1 0 and a 0 1 1 0, which is placed closed here. So we'll invert these two columns and these two columns at the same time. So this is how 4D maps are going to be represented. M0, 1, 2, 3, 4, 5, 6, 7. Oh, it's 8, not 18, my bad. 8, 9, 10, 11, 12, 13, 14, and 15. So why have I made these two arrows? It's just to let you know that grouping can also be done in this fashion. Like this 0, 1, 0, 0, 1, 0 can be grouped together. If there are any terms there, they can be grouped together. And even this 0, 0, 0, 1 can be grouped together. Right, that's exactly what I mean. So we'll go with an example so that it becomes clearer. And before that, like these 4D K-maps is kind of like a toroid. So what I mean by this figure, you guys need not worry much about it. All it means is that, these terms and these terms can be grouped together. So it's like, imagine you have an A4 rectangular sheet of paper with you, and both these two edges, can be overlapped together. Like they can be grouped together, and both the top edges and bottom edges can also be grouped together. So you're going to be left with a toroid. That's it. You need not worry much about this. With the grouping, you guys will understand. So this is another example. This might look really big, but trust me, it is very easy once you guys have figured out how to do it. And you've understood 2D and 3D K-maps. So you guys can start with the first term, right? The function W is 0, X is 0, Y is 0, and Z is 0. So what do you think the first term is going to be for such a function in SOP format? Just the first term. Clear. Okay. So any ideas what the first term is going to be for this function in an SOP form? just the first term. Like what this zx, w0, x0, y0, z0, and the function being 1, what does that translate to in an SOP form? Yes, wx prime, w prime, y prime, and z prime. That's right. Anybody else with some other answers? Or let's go with the second term then. Like, what do you think the second term is going to correspond to? W0, X0, Y1, and Z0. What do you think this stands for? Yeah, that's right. X prime, Y prime, Z prime, W prime. That's correct. What do you think the second term is going to be? Come on, guys, put your answers in the Q&A section. Yeah, I can see new answers. Oh, that's for the previous thing. Okay, someone's given me an answer for this. W prime, X prime, Y, Z prime. Okay, I'll go and verify. W prime, Y, X prime, Z prime. That's absolutely right. So this is how the function is basically written, right? There are so many ones here. So if you think of trying to solve this algebraically, it's going to be really hard. Like that's where K-maps are going to be really useful. That's why I told these are kind of some pictorial form of representing your truth table. So that's exactly how each term of the truth table, each term from the truth table is read. And this is the final function which you guys are going to be getting. Sorry, this is the slide. So this is the final function which you are going to be getting. It is something like this. This might look really big, but trust me, it's not really hard. So we'll go and mark all of these terms on the K-map here. So I'll go present this, just a second. And I've assumed like the first term is W, second term is X, third term is Y, and fourth term is Z in this combination, you know. Can't present for some reason. Just a minute, guys. Well, why am I not able to present? I just reshare my screen. 1 minute, people. So share my screen once again. Yeah, and I hope I'll be able to present now. I have no idea why I'm not able to present it. Yeah, fine. So you can see W prime, X prime, Y prime, and Z prime. It's going to be this term. Next you have W prime, X prime, Y prime, and Z. Right. So the first three zeros and the next term being 1. That's the term which we're searching for. So it's going to be this term. And then you have W prime, X prime, Y, Z. So that's going to be 0, 0, 1, 1. Right. That's the term it's going to go and correspond to. So 0, 0, 1, 1. My bad. I have marked it in the wrong place. The one here. It's not here. It's gonna be here. Sorry about that, guys. Or wait, did I write the function wrong? Yeah, I've written it wrong here. The function was, it's 1 here. And this is not that. Sorry about this typo. So each term in this manner, you're going to be going and verifying from the function and putting ones there. So as I said, grouping is done in powers of 2. So this is the first group where you're going to be grouping 8 terms together, right? That's it is a power of 2. So you're going to be grouping all these 8 terms together. Well and good. But if you see this, no, there are only 3 terms. So I'll have to find another way of grouping these. I can group 2 together, but as I told you, you'll always have to group more number of terms together, right? So I can group 1, 2, 3, 4, because as I've told you in the previous figure itself, you can group this column and this column together also. So this is one of the tricky parts when it comes to higher degree K-maps. You'll have to properly group stuff together, but it's actually not hard. It becomes much easy, once you have done enough examples. So these two and these two are grouped together. You might ask, can I not group all these 6 together? But thing is, it will become 6 things together, right? You don't want 6. So you'll have to group in powers of 2. So I'll split and I'll group these 2 together and these 4 together and this 2 together. If you want, you can group it in any other way. I'm just showing one method of grouping all of this together. And this is how it's going to look like. This might look a bit messy, but trust me, it's easy to figure out what we have done. So let's talk about this red grouping. You guys with the top stuff which I've written, right? 0, 0 and 0, 1. Because if you're going to this, right, you'll have to figure out for each term. It becomes much easy if you're comparing these stuff together. So in this, what do you think is not changing? Y part. And Y is kind of low. So that becomes a Y prime. And here everything is changing, right? If you're comparing W and X, like here, it's W prime, X prime. It's going to WX. So, both of them are changing simultaneously and no place where this thing is changing together. So this red thing overall corresponds to only one term, which is Y prime. And if I'm going to this orange square, similarly, you will see that the orange thing will correspond to something like 1 minute. It's going to be Y and Z prime. And what is this green thing going to correspond to? You can see that these 4 things have been grouped together, right? It is going to correspond to Z prime, W prime. Why? Because if you group these 4 things together, you see that in this section, right, only the Z part is not changing. And in this section, right, only the W part is not changing. So that's basically how this grouping is done. Am I clear with this part, or do you want me to repeat? Like, do you want me to give you guys another example? Or is this fine? It might look difficult, but it's actually not very hard. And you guys need not worry, like 4D K-maps are not commonly used. You guys are going to be using only 3D K-maps. This is just for letting you know that this concept can be, enhanced to more number of variables. That's it. And I'm also trying to tell you guys that with increase in the number of variables, your complexity in representing K-maps is going to increase. That's why, for 5D and 6D K-maps, you're not going to be using you're not going to be using this method. There are other methods which are going to be which are available, but we're not going to be discussing that. So Arun says that's clear. Okay, so I'll wait for a minute. If it's clear, then we'll go on to the last topic for today, which is the don't care condition. And it's actually just the same. There is no difference in this. More than 6 variables are very hard. Yeah, it is very hard. Actually, more than 6 variables, you don't use K-maps. Actually, more than 4 variables also you don't use K-maps because its efficiency reduces. Because it's going to be really hard to map stuff together. So there are other methods which are available. So I guess there are no doubts with this. So we'll go forward with the don't care condition. That sounds weird, like don't care in K-maps, but it's actually nothing. It's just a repetition of the same thing with certain small changes. That's it. So what it means is that some cases the function is not specified for certain combination of variables. It's like incompletely specified functions give rise to don't care conditions. So what do we mean by that? Let's say I'm having such, I'm going back to 3 variables because it's much easy to explain also. So let's say, for these two combinations of x, y, and z, the function does not have any value. Right? That's why we are telling this function is incompletely specified. And here's where the don't care condition comes into picture. So again, like the regular thing, you will again go and write stuff like, this thing will correspond to x, y prime, z prime. This corresponds to x prime, y prime, z prime. This corresponds to x prime, y, z. And this corresponds to x, y, z. Right, so this is the combination which is possible for f. and f is remaining the same. But there is some don't care condition, right? So that is represented d of x, y, z. So what are the terms which are not completely specified? It's x prime, y prime, z prime, and x prime, y, z prime, right? So these are the two things which are not properly specified. So as I told you, if we are talking about SOB form, right? Whatever terms are here, you will go to the K-map and put a 1. If you are writing some POS form, it's going to be 0. So what do we do for don't care condition, right? Or these incompletely specified functions? Instead of these terms, you're going to go and put an X in those places. Like here you'll put an X and here you're going to go and put an X. So what difference is it going to make? This is actually not going to make any difference, and you can group stuff including these X's also. So the number of terms in your group is actually bound to increase. This is kind of only that. There is no other difference. So you can see these four terms can be grouped together, and these two terms, they have no other connection, right? So I'll have to group these two and these two together. And ultimately, this is the grouping which we are going to come and reach. So what is this grouping? Here x is remaining same. That's the only thing, and it's kind of low. So this is x prime. And what does this represent? This x is changing, but y and z is remaining constant. So this becomes yz. And what is this term again going to be? It's going to be y prime, z prime. You just don't care about this x, right? It doesn't matter. Just a minute. This doesn't matter. So here the only thing which is changing is x, and y prime, y and z remain constant with 0 values. So that's going to become y prime and z prime. So with that, we actually come to the end of today's session. So if there are any doubts, you guys can put it in the Q&A section. You want me to repeat something, you guys can put it. And yeah, the attendance form has been sent. We'll be closing it by 12:30 or 12:35 max. We use, yeah, Quinn and Mikulski method. Exactly, that's the method we're going to be using. So any other doubts you guys have, you can put it in the Q&A section. We'll be here to clear them. Any doubts, people? Why only x? It's just a method of representing. It means that cross mark, right? Not the variable x. It just means that cross mark. Like not the small variable x, not that. Okay, if you want, you can represent it anyway. As I told, all of this is just convention so that you guys don't get confused. If you want, you can put it any way you like. Like instead of X, you can put a hyphen. It's up to you guys. Any other doubts, guys? Anything you guys want us to repeat, some concept which is not clear? We're here. Yeah, if you guys are done filling the attendance form and you have no doubt, you guys can leave.
Guys, any doubts? And regarding the first part of the session, there was a bit of confusion regarding XOR and XNOR gates. I have changed the slides appropriately. So I hope apologies for the errors on the slides. And I'll be sharing the correct algebraic proof in the WhatsApp group. Yeah. Let me share my screen and teach you the theorem proof.
There's a doubt. Should we always group two terms in 3D? No, you have to group it in powers if two. Like you can group two terms together, you can group four terms together. All of that is possible. Or you can group one term also, like that is there is no other term in the vicinity, like in the example which I showed you, right? The second example. You can always go and do that. Ma'am, how many tables we need for K-maps of 6 variables? Actually, for 6 variables, right, you'll have 2 power 6 terms which are possible. So accordingly, you will have to draw a table which is not feasible, right? So we don't use K-maps for 6 variables. It is theoretically possible. That's it.
Yeah.
Can you
So
show
the
us how and where? Deepti, 1 second, okay, 1 minute.
yeah, sure.
Can you show how and where are the applications? The applications of K-maps you'll be seeing it tomorrow. I mean, in the next session, not tomorrow, in the next session. Yeah, Deepti, you can continue. Sorry
Yeah.
for the interruption.
Hey, it's okay. So actually in the slide it was a plus b dotted with a plus b prime, which was not right. It was supposed to be dot. So this part was supposed to be a dot b prime. So when I start simplifying it, I'll get, if I use De Morgan's theorem, or first let me split. I'll get a into a dot b prime plus b into a dot b prime. Now I'd use De Morgan's theorem for this and get a into a prime plus b prime plus b into a prime plus b prime. Okay, so a prime will be 0 and I'll be left with ab prime from the first part and ba prime and bb prime is 0. So when I take prime of this term, this part, I'll get x and or k, for which the proof I have already written in this slide. Hope I'm clear with that. I will also share these proofs in the WhatsApp group. Yeah, thank you. Any doubts, guys? Please ask. Please post in the Q&A section. Thank you guys for the good feedback. Thank you, Saurashish and Srinitu. Any doubts? We will be staying here for a few more minutes. If you have any doubts, feel free to post it in either Q&A section or chat section.
Guys, if you have any doubts, you can put it in the Q&A section. Otherwise, if you have done filling the form, you can all leave. It's fine.
The attendance form will close at 12:35. So I request all of you to fill it as soon as possible.
Deepti, can you repost the attendance form link? Some people are asking. And close it in 1 more minute.
Okay, since nobody has doubts, I think I'll end the meet now. Bye, guys. Take care.